This is SpaceTime Series 19, Episode 85, for broadcast on the 30th of November 2016. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe. You can download SpaceTime as a free twice-weekly podcast just about everywhere, including iTunes, Stitcher, Pocket Casts, Bytes.com, YouTube, SoundCloud, Audio Boom, and from spacetimewithstuartgary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C. Coming up on SpaceTime, a new type of star found near the center of the galaxy, a subsurface ocean on distant Pluto, and the launch of the world's most advanced weather satellite. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new type of star has been discovered in the heart of the Milky Way galaxy. The findings, reported in the monthly notices of the Royal Astronomical Society, could shed new light on both the early formation history of the Milky Way and how globular clusters are formed. The study's lead author, Ricardo Chavon from Liverpool John Moores University, says the discovery could help explain the role globular clusters have played in the formation of the Milky Way 13.2 billion years ago, and by extension, the formation of other galaxies as well. This new family of stars detected near the galactic core contain unusually high levels of nitrogen. Similar chemical compositions are found in stars in globular clusters, tightly packed dense balls consisting of millions of stars, which are usually only found orbiting around the outskirts of galaxies. The authors speculate that this newly found stellar population may have belonged to globular clusters that were destroyed during the violent initial formation of the Milky Way's galactic center. If correct, it means there may have been 10 times as many globular clusters in the Milky Way during its early history compared to the 150 or so thought to exist today. It means that a substantial fraction of the old stars inhabiting the inner parts of the galaxy today may have actually initially been formed in globular clusters that were later destroyed. The authors used the Sloan Digital Sky Survey and the Apogee Apache Point Observatory Galactic Evolution Experiment to collect infrared data for hundreds of thousands of stars in the Milky Way's galactic center. There they detected this new population of stars, the likes of which had only previously been seen inside globular clusters. The center of the Milky Way is poorly understood because it's shrouded from view by intervening clouds of gas and dust. Apogee overcomes this veil by observing the region in infrared, which is less absorbed by dust than visible light. The observations allowed the authors to determine the chemical compositions of literally thousands of stars. Among these, they found a considerable number that differed from the bulk of stars in the inner regions of the galaxy due to their unexpectedly high abundance of nitrogen. While not certain, the authors nevertheless suspect that these stars did result from globular cluster destruction. However, they could also be the byproducts of the first episodes of star formation taking place at the beginning of the galaxy's history. Therefore, these could be some of the oldest stars in the Milky Way, forming right alongside the galactic core from the remains of the very first stellar generations, so-called Population 3 stars, which formed in the very heart of the galaxy. The authors are now conducting further observations to test these hypotheses. A new analysis has confirmed the existence of a liquid water ocean lying deep beneath Pluto's frozen surface. A report in the journal Nature claims the latest data collected by NASA's New Horizons spacecraft during its historic close flyby of the Pluto system in July 2015 provides the most detailed investigation yet of the role a subsurface liquid water ocean's likely to have played in the evolution of key features on the dwarf planet, such as the vast low-lying plain known as Sputnik Planitia. Sputnik Planitia, which forms one side of the famous heart-shaped feature seen in the New Horizons images, is suspiciously well aligned to Pluto's tidal axis. The likelihood of this being just a coincidence is only about 5%, so the alignment suggests that extra mass in this location interacted with tidal forces between Pluto and its binary partner and largest moon Charon to reorient Pluto, putting Sputnik Planitia directly opposite the side facing Charon. Of course, the thing is, a deep basin seems really unlikely to provide the sort of extra mass needed to cause that kind of reorientation. The study's lead author, Francis Nemo, from the University of California, Santa Cruz, describes Sputnik Planitia as a big elliptical hole in the ground. So the extra weight must be hiding somewhere beneath the surface, and a subsurface ocean would best explain that. Another paper in the same issue of Nature, this one by James Keane from the University of Arizona, also argues for reorientation and points to fractures on Pluto's surface as evidence that this has happened. Like other large basins in the solar system, Pluto's Sputnik Planitia was most likely created by the impact of a giant asteroid, which would have blasted away a huge chunk of the dwarf planet's icy crust. With a subsurface ocean, the response to this would have been an upwelling of water, pushing up against the thinned and weakened crust of ice. At equilibrium, because water is denser than ice, that would have still left a fairly deep basin, with just a thin crust of ice covering the upwelled mass of water. Nemo says at that point there was no extra mass at Sputnik Planitia, so the ice shell would have got colder and stronger over time, and the basin would have eventually filled with nitrogen ice. It's that nitrogen which represents the excess mass. Nemo and his colleagues first considered whether or not the extra mass could be provided by just a deep crater filled with nitrogen ice, with no upwelling of a subsurface ocean. But their calculations showed that this would have required an implausibly deep nitrogen layer more than 40 kilometers thick. Eventually they determined that a nitrogen layer about 7 kilometers thick above a subsurface ocean would provide enough mass to create a positive gravity anomaly consistent with their observations. This scenario is analogous to what occurred to the Earth's moon, where positive gravity anomalies have been accurately measured for several large impact basins. Instead of a subsurface ocean, however, the dense mantle material beneath the moon's crust pushed up against the thin crust of the impact basins. Lava flows then flooded the basins, adding the extra mass. On Pluto, the basins filled with frozen nitrogen rather than lava. There's plenty of nitrogen for this in Pluto's atmosphere, and either it preferentially freezes out in this low basin, or it freezes out in the highland region surrounding the basin and then flows down as nitrogen glaciers. In fact, there are images from New Horizons showing what appear to be nitrogen glaciers flowing down from the mountainous terrain around the Sputnik Planitia basin. As for the subsurface ocean, Nemo suspects it's most likely water mixed with some kind of antifreeze, most likely ammonia. The slow refreezing of the ocean would put stress on the icy shell, causing fractures which are consistent with the features seen in the New Horizons images. There are lots of other large objects in the Kuiper Belt that are similar to Pluto in both size and density, and Nemo thinks they too may have subsurface oceans. What all this means is that science's understanding of the Kuiper Belt has come a long way from the old idea that these distant worlds are little more than frozen snowballs. The world's most advanced weather satellite has been launched from the Cape Canaveral Air Force Base in Florida aboard an Atlas V rocket. NASA's new fifth-generation geostationary operational environmental satellite, GOES-R, will provide atmospheric and surface measurements of the Earth's western hemisphere for weather forecasting, severe storm tracking, space weather monitoring, and meteorological research. GOES-R blasted off from Space Launch Complex 41 aboard a United Launch Alliance Atlas V 541 rocket using 4 strap-on AJ-60A solid rocket boosters augmenting a Common Core first stage equipped with a Russian RD-180 engine burning RD-1 kerosene propellant and liquid oxygen for 4 minutes and 22 seconds.
Stable at step 3. ECS reduced for launch.
Roger. Status check.
Go Atlas. Go Centaur.
Go GOES-R.
15 seconds and counting. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff of NOAA's GOES-R, America's most advanced weather eye in the sky, elevating environmental intelligence to new heights and saving lives.
Neo's gone to close-up control. Engine response looks good. Now flying the zero angle attack phase of flight. Body rates look good. Booster has throttled down as scheduled. Response looks good. Roll program is complete. Body rates controlling down the middle.
Listening to the voice of Marty Malinowski.
Mach 1.
Standing by to pass
Max
through
Q.
max Q. This is the maximum aerodynamic pressure area. When mechanical stress on the rocket reaches its peak because of the rocket's
180,
velocity
continue
and
to look good.
resistance created by the atmosphere.
Down the middle.
NASA's Atlas V
Booster has begun throttling back up. Right on
And-
schedule. Engine response looks good.
GOES-R spacecraft continue into flight. The United Launch Alliance Atlas booster doing its job.
We have
The first two
indications
solid
as-
rocket boosters will be jettisoned, followed about a second and a half later by boosters 3 and 4.
Coming up on SRB jettison, and we have the first pair and the second pair. It's like a good separation.
Jettison of the payload fairing, which has protected NOAA's GOES-R during its flight through the atmosphere.
And we have begun throttling to 2.5 Gs in preparation for payload fairing jettison. Booster engine signatures look good. And we have payload fairing jettison. Looks like a good jettison.
3 minutes, 42 seconds into flight.
And we have throttled back up. Next, approaching our 4.6 G constant throttle. Boost phase cool down is underway.
Standing by for
Boost phase
booster
chill
engine
down.
cutoff.
And we have BECO. Engine shutdown looks good.
Following core stage separation, the rocket's Centaur upper stage burst into life, igniting its single liquid hydrogen and liquid oxygen RL-10C1 engine for the first of 3 engine burns.
Standing by in about 6 seconds for the Centaur's second stage to separate from the booster.
We have indication of AC sep.
Good separation.
Locks pre-start are underway. GN2 purge firing is as well. And we have ignition and full thrust on the RL-10.
This Centaur single RL-10C engine burn, producing 22,900 pounds of thrust, will burn for just under 8 minutes.
OSML.
Beginning to see our RCS thermal conditioning firings.
Adjust security roadblocks for pad access control. Roger. Readiness pole for padding.
RL-10 performance looks good. Chamber pressures, fuel injectors, fuel venturi pressure. Box pump discharge, all within band.
Ready. Atlas pneumatic. Ready. Centaur propulsion.
Ready.
Centaur pneumatics.
Centaur PU is now in closed loop operation, except it is still requesting a slightly oxidizer-rich condition. Centaur body rates continue to look good, controlling down the middle. Current altitude 139 miles, downrange distance 888 miles, current velocity 14,209 miles per hour. Coming up on the format change. And we did have a slight dropout in data, but data has resumed. All signatures look good. Centaur continues to look like it's making good progress down the middle of the range track. Current altitude 147 miles, downrange distance 1133, current velocity 14,715.
Atlas Centaur GOES-R rocket as they transit across the Atlantic Ocean. The Centaur is powering the GOES-R satellite.
Controlling near nominal MR.
This flight will continue on for more than 3 hours as the Centaur
And
engine
yield emitting
will
phase.
have a total of 3 burns before spacecraft separation later tonight.
Body rates are still controlling down the middle.
3.5 hours after launch, GOES-R was finally deployed from the Centaur upper stage using its Luros 1C apogee motor to perform a series of orbit-raising maneuvers which eventually placed it into a geosynchronous transfer orbit with a perigee of 8,099 kilometers and an apogee of 35,286 kilometers. GOES-R is the latest satellite in the GOES constellation used by NOAA, the National Oceanographic and Atmospheric Administration, for its National Weather Service, the US's Weather Bureau. It'll be used for monitoring and forecasting America's weather, as well as studying the interactions between land, ocean, atmosphere and climate. Based on a Lockheed Martin A2100 bus, the 5,192 kilogram spacecraft is 6.1 meters long and carries 6 scientific instruments, as well as enough fuel for a 15-year lifespan. The primary instrument aboard GOES-R is an advanced baseline imager designed to collect 3 times more data and provide 4 times better resolution with over 5 times faster coverage than existing weather satellites. This allows GOES-R to scan the Western Hemisphere every 5 minutes and as often as every 30 seconds in areas where severe weather forms, compared to every 30 minutes on existing GOES satellites. The imager can see across 16 spectral bands from visible to infrared with a spatial resolution of half a kilometre at its primary visible light wavelength of 0.64 nanometers and 2 kilometres in the infrared, almost twice the resolution of the earlier 5-band instruments. The new spacecraft also features a geostationary lightning mapper, which uses infrared sensors to record and map lightning events, thereby improving storm forecasting and severe weather warnings. Another set of science instruments specializes in monitoring space weather events which originate on the Sun. These include a solar ultraviolet imager and an extreme ultraviolet and X-ray irradiance sensor package to take spectrographic readings of the Sun's helium, hydrogen and magnesium emission lines. These elemental lines correspond to different regions of the Sun. This will allow scientists to model the Sun's ultraviolet and X-ray spectrums and measure solar irradiance and solar flare activity, which can produce coronal mass ejections. The third set of science instruments aboard the GOES-R focus on the space environment and cosmic ray emissions. This includes a space environment in situ suite with 5 sensor packages studying the space environment around the satellite using an energetic heavy ion sensor to measure the flux of energized particles both in the magnetosphere and those originating from both the Sun and beyond the solar system. There are 2 magnetic particle sensors to measure high and low energy proton and electron flux. And there are 2 galactic proton sensor packages to measure the incidence of protons in the Earth's magnetosphere from the Sun and from cosmic sources. And there's a magnetometer mounted at the end of an extendable boom to measure activity in the outer region of Earth's magnetosphere. GOES-R also carries a communications payload using an array of transponders to relay data between weather ground stations, the Emergency Managers Weather Information Network, and search and rescue services tracking EPIRBs and other distress signals. Once successfully operational, the satellite's name will be changed from GOES-R to GOES-16. The GOES constellation usually consists of 3 satellites in geosynchronous orbits over the United States at any one time. One spacecraft designated GOES-East is stationed at longitude 75 degrees west. It covers the eastern United States, the central and western Atlantic Ocean, as well as the Gulf of Mexico and the Caribbean. It's currently serviced by GOES-13. A second satellite position called GOES-West is stationed at 137 degrees west, providing coverage of the western United States, as well as the eastern and central Pacific Oceans, including Alaska and Hawaii. Its slot is currently serviced by GOES-15. A third satellite is kept in orbital reserve to replace either GOES-East or GOES-West if needed, and that's currently serviced by GOES-14. After a year of orbital checkouts, GOES-R, which by that time should be renamed GOES-16, will replace GOES-13 in the GOES-East slot, allowing GOES-13 to become a second on-orbit spare. An Ariane 5 rocket is blasted into orbit from the European Space Agency's Kourou spaceport in French Guiana, carrying 4 Galileo navigational satellites.
À tous de DDO, attention pour le décompte final. 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage des EAP, décollage. Les paramètres de propulsion sont tous nominaux. La trajectoire est nominale, tous les paramètres en bord sont normaux.
Darting behind the clouds, in and out, Ariane 5 beginning her mission, lifting off at 10:06 local from the ground, roaring off the ground here in French Guiana, beginning her mission, the 9th for Arianespace this year, carrying the 4 new satellites in the Galileo constellation, leaving her trail of smoke and fire. The 2 boosters providing 99% of the thrust right now, propelling the launcher along her trajectory at an ever higher velocity. 760 tons was the mass at liftoff. She's burning 5 tons of fuel every second. Yes, that's every second. 2.5 tons burning in each booster per second. Plus the core stage, first stage burning another 300 kilos of fuel per second. Ariane 5 now following the program in the onboard computer, which gives all the orders, including stage separations. We are in the first of 4 flight phases.
Les
So you
paramètres
can
à bord sont
follow
normaux.
Ariane as she heads northeast across the Atlantic. Meanwhile, the DDO saying all well on board. Right now, the first flight phase, the single Vulcan core stage engine, and the 2 boosters are burning. The boosters are going to burn for another maybe 10 seconds, not even, and then flame out and
Séparation des
extinguish.
EAP.
And there they are, and the DDO has confirmed that. The boosters fall 500 kilometers from shore in a protected area.
The flight was the first time the European Space Agency and Arianespace had used the Ariane 5 launch vehicle for Galileo missions. All previous 14 Galileo spacecraft were launched aboard Russian Soyuz frigate rockets, which can only carry 2 satellites at a time. This was also the second flight of the Ariane 5 ES version of the heavy lift launcher, which employs a lighter equipment bay and a shorter payload fairing. The first pair of Galileo satellites were deployed 3 hours, 35 minutes and 44 seconds after liftoff, with the second pair released 20 minutes later. The successful deployment of the 4 new satellites brings to 18 the total number of Galileo spacecraft now in orbit. Over the next few days, engineers will nudge the satellites into their final working orbits and begin a series of tests to ensure they're ready to join the constellation. These tests are expected to take about 6 months. The satellites already in orbit will allow the European Commission to declare the start of initial services towards the end of the year. 2 additional Ariane 5 Galileo launches are slated for 2017 and 2018. The full system of 24 satellites plus spares is expected to be in place by 2020. Galileo will provide Europe with its own civilian global satellite navigation system, designed to provide an alternative to the American GPS system. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, and from SpaceTimeWithStuartGary.com. The show's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C.
This is SpaceTime with Stuart Gary. For more, you can follow us on Facebook, Twitter and Tumblr. Just search for SpaceTime with Stuart Gary.